Welcome back to TrueNAS Tech Talk. This week, Kris and I will be digging into the details on TrueNAS 25.10 RC1, landing in a couple of weeks. We've got some helpful fixes and new features to discuss. We'll go into the laundry list of changes in the OpenZFS 2.3.4 release that's coming with it. All this and a teaser on a new feature that we're building for Halfmoon coming up next. So we've got the next release of TrueNAS 25.10 RC1 looking to ship out in a little bit less than 2 weeks before the end of September here, Kris. There's quite a few notable items here coming. I know we're doing a new little point release of OpenZFS. We're going to get to 2.3.4, and we'll have more on that in a moment. But before we get to that list, I think you got a couple of new changes in the VM system that people will be excited about here.
Yeah, I mentioned this during beta, something that didn't quite make the cut that we wanted in, but it landed for RC1, so I'm happy again. This is good, which is for the VM side, being able to import and export disk images. That always has seemed like just a gap we've had in the VM implementation going back to forever. So the way it'll work in RC1 is you'll have the ability to point to a disk image, a VM image, could be a VMDK, a VDI, QCOW2, whatever, right? It's pretty much supports about everything. Point to that somewhere on your pool. So if you've uploaded one via SMB or SFTP or however you like to do that, that's cool. And then in the back end, we'll be able to ingest that and convert it into raw, put it on a ZVol so that you can point your VM at that, and away you go. That way you're not having to run it off of a disk image or a raw image file directly off the file system. Yep. ZVol is going to give you better performance.
And no more needing to go to the command line for tricks to convert it, piping it through that QCOW image conversion. And then, because we're doing it from the pool, we don't have to worry about like HTTP session sizes or timeouts or things like that. We'll just be able to say, hey, take it directly off the pool, clone it into a ZVol. I mean, if you were doing multiple VMs for some reason out of this, you'd even get the benefit of it's going to be cached the first time. So your conversion should be even faster.
Yeah, no, it's handy. It's one of those convenience things we've just wanted in there for a long time, but it works great the other direction too. If you want to go and take your VM ZVol image and then dump it to some other disk image format to export, import, export, make your VMs a bit more portable. Again, it was just a missing piece we didn't have. We're happy to see that land. Glad that made the cut for RC1. You'll have that in your sweaty hands here in a few weeks, so be patient just a little bit longer.
Awesome. I think we got a few fixes in for that new NVMe over TCP service as well, right, Kris?
Yep.
People were experimenting
NVMe
with
over
that.
TCP. Yeah, that's a brand new service, and this is always what happens when we put something brand new in the software. There's always kind of that initial introductory period where we go and we shake out issues, we look for edge cases. Thank you for everybody who sent in feedback. We fixed a whole slew of things around that service. So again, keep the testing up. Let us know in RC1 if you run into any new issues, but there's almost too many things to go through here, but a lot of good fixes there.
Yeah. On the subject of bug fixes, we've also fixed the bug around submitting the tickets, I believe. The feedback button was fixed in RC1. So we understand there were a few people who said, hey, if this is a beta and I'm supposed to be testing, how come it's not letting me submit the feedback? So we have caught that one. We corrected that. So you should be able to use the little, smiley face feedback icon in the taskbar again for your much more convenient means of submitting your tickets and your debugs in.
Yeah. Bugs in the bug submitting, go figure.
Exactly.
But speaking of interesting bugs, and this one's kind of amusing and annoying, and it's one of those things where you look at it and go, oh man, I never would have guessed that. But we had fixed previously a super annoying bug around the fact that some people's devices have empty SD card readers. You remember what those are?
Yep.
Right? It seems like a long time ago, right? But some people still have them present, and I don't know why you'd have them on your NAS unless you are ingesting via SD card, but cool. Anyway, the issue was you couldn't create a pool properly when there was an empty SD card reader slot present. The middleware got confused because there was a device presenting itself, but you couldn't actually query it. There was nothing there, especially when there's no SD card inserted. So we fixed that previously, but then for RC1, of course, you fix one thing and you get rewarded by having to fix more things, right? So we then needed some subsequent fixes to go and fix the same empty SD card reader issue when you have temperature reporting running. It turned out that was messing up. So wonderful. Okay, that's now been corrected as well. Glad to have that fixed there. Again, one of those things where we've seen a slew of people say, hey, my temps don't work. And we're sitting here pulling our hair out like, well, why? What's going on? It works on our system. So most of our systems don't have an SD card reader slot. So go figure.
Yeah. And that's what's submitting in these, the bug reports with your debugs in there so that we can comb through the middleware logs, see where that piece is falling over. And when we say, hey, it's trying to query this device that somehow exists but doesn't. It's like Schrodinger's SD card here, where it says, hey, I'm a block device, but I'm not going to respond to anything you're asking me.
Yeah.
And it just tripped up the middleware and said, hey, I don't know what to do with this. So rather than trying to continue in a state where it might be potentially doing the wrong thing, it said, I've got to stop. And now we've figured out how to get around that point and say, okay, well, this is an SD card reader with an empty slot, and it's going to have some weird behavior. But other bugs that people are going to be really happy to get rid of, those of you who are looking to migrate from TrueNAS Core over to TrueNAS Community Edition, we fixed the upgrade bug that was in regards to your system starting life as Core, and it had a different partition layout on the boot device.
Well, to be clear, this was if you've already made the migration, but you started life as a Core box. So say you migrated to Scale some point early on and you've been humming along, and then along the way you hit this boot upgrade bug where GRUB, basically barfed and said, I can't update the bootloader. Well, we finally were able to take a look at that. Some of the really old Core systems, we had different partition layouts on the boot devices, which makes sense. We just had to teach GRUB to accommodate those a little bit more gracefully and continue on. So that should be fixed. That'll, I think, fix a slew of people who, again, have some of those boot devices that go way back, some even into the FreeNAS days. We had to go back into the archives to quash that one and figure out what went wrong.
Yeah, it's not going to be, I don't think we have a hard limit on exactly, this is the patch release. We might be able to find it. But in general, if you saw a weird thing when you're trying to upgrade to the 25.10 beta and it was complaining about your BIOS boot partition or a GRUB failure, that should be corrected in RC1. So go ahead, and if you're in the mood for giving an early release a shot here, you can go ahead and give it a try now.
Absolutely.
Yeah.
We would appreciate the feedback. So as we teased, Chris, in addition to it being an RC1, it's always nice when you get a new ZFS point release to drop in as well. And this release delivers. We got 2.3.4 now shipping. So we have a whole list of items to go through just from the ZFS side. You want to start us through that?
Oh yeah. Well, for a point release here, for like three numbers deep in the version, it's got quite a lot of good things in here. Like just to start on the surface level, we have a weight calculation fix for the Metaslabs. Now, the Metaslabs are something that ZFS uses in order to decide where it's going to place the data onto your disks itself. It basically chunks each disk up into these slabs, it calls them. But there was an issue with the weight calculations. Basically, it was causing some Metaslabs that could be useful write candidates to be unnecessarily skipped. So what it does is it doesn't necessarily increase, peak speeds, but what it does is it sort of reduces the variance of the sync time when you're actually flushing your transaction groups to the pool. I think the GitHub poll says it could be like, 70%-ish or so on a pool that's got a lot of fragmentation on it. So if it's trying to seek around and find a Metaslab to write to, it's now going to not skip those ones that were viable candidates before and say, oh, I can hit this one now, I can hit that one now, rather than having to go through and sort of index more of them to find a viable candidate or what it thought was a viable candidate after having skipped a few. So that's a great little fix on there. That's nice. From a performance thing.
Yeah, and then this next one's about preventing panics, which is always a good thing. So particularly around ZIL forced writes when you're trying to suspend the pool. So for example, when you're trying to suspend the pool and you have a partially filled write block, you need to be able to flush that. And this fixes a race condition where the pool suspension could actually cause a panic because it's still waiting for the uncommitted writes to get flushed out.
Yeah. And then there's another panic fix for a use after free. So it's about some of these things are about avoiding these race conditions again. That's one of the most challenging things to troubleshoot in programming because it's always a matter of, okay, in a race condition, sometimes you get the error, sometimes you don't. It's those intermittent bugs that are the most frustrating to do. But it has to do with deferring deallocation of inodes until a certain grace period has passed. So it fixes like, null pointer dereferences. And, again, it's another way to stop a kernel panic. So,
yeah, parallel operations are a pain. We should go back to single core processors.
Yeah, everything's
so much easier back in the day.
Single threaded. Everybody just has to wait in line in an orderly fashion.
That's right.
Back to the queue.
Do everything in the right order.
Back to the queue, folks.
But anyway, we also have some fixes to changing the defaults around ZFS bclone wait dirty. This basically means FI clone range defaults are going to now wait for dirty data flushes to occur. This prevents clone failures, but it may actually have a side effect that it slows a little bit of small file operation. So keep an eye on that.
Yeah, basically with small files, you're having to wait for that flush, and it's just about open file, flush data, close file kind of things. It's that general sort of behavior you'll see in pretty much any file system. Writing big chunks of data is much faster than writing a bunch of small files that make up that same big chunk of data. But you want to do it in a safe manner.
So we have some fixes to the Metaslab passivation fix. I can't even pretend to understand what this is doing in the Metaslab, but something about calculation during Metaslab group passivation. I'm not sure what that means in the ZFS context. To use proper weight function instead of always using the segment-based weight. Enlighten me, Chris. I haven't dug that deep.
It's basically more of what I mentioned before about sort of that calculation fix. It's trying to use the proper functions now in the underlying one to say, okay, not only are we not going to skip them for the wrong reason, we're also changing the way we calculate those weights. So all in all, it's about getting a more accurate picture of how populated each of these slabs is so that it can make the correct decision now to say, this is where we're actually going to physically lay the data out onto your pool. And then, of course, when you talk about something like you're physically laying it out onto a solid state drive, then that flash translation layer is going to get in the way. But it's still the idea of saying, if you have this many chunks on your drive, they're all a certain percent full each. It's being able to more evenly distribute the data across the correct location on that drive to do it in the most optimal and quickest way possible.
Okay, yeah, that makes sense. And then next, we also have boot checksum benchmark optimization. This is actually good. So boot time, we're now only running checksums on the first 256K at startup. The full benchmark is now deferred until later on, explicitly requested by a caller via procfs, which is a good fix. We're just going to save a little bit of time.
Yep, saving time on boots. We don't reboot that often in TrueNAS, but it is good to make it as quick as possible when you do.
Mm-hmm.
We got some
people get lazy. They want it to go quick.
Of course. Well, I mean, we all want a faster boot up, don't we?
Yeah, we do.
We got some debug enhancements as well for certain panic messages. If you do get a panic for, an unexpected issue with ZFS, there's been some additional context added to some of those panic messages. That's usually a case of if there's something else wrong, we're just making it easier to find it. Kind of an internal engineering fix. It's always better for us to have more information when we're troubleshooting these things. What else do we have here?
No, that's super important. So arc dnode limit enforcement restores dnode pruning fallback for non-root memconfig tasks where the kernel shrinker fails, prevents dnode cache overflow and excessive memory pressure.
Yay.
That sounds like all good stuff.
It's absolutely, it's a great thing. We've seen people sort of sometimes say, hey, there's this weird memory pressure issue, especially if you're running virtual machines on there. Basically, when Arc is trying to share that memory space with something else, we're just trying to make it as well behaved as possible so that when you have an outside influence on Arc to say, hey, you need to shrink your Arc, we want it to be able to do that really quickly, not have any overflows, not have it push back. It should just be able to say, well, everything that's in Arc has a safe permanent home on disk. I'm going to dump this for you and give you that memory you're requesting.
Yeah, we just need to evict it and shrink within a timely manner is the key before the other process says, I'm out of memory, I'm dying now.
Yeah. Hey, speaking of memory fixes, there's a memory reclaim deadlock fix. So it prevents a swap D and page daemon deadlock. It skips it in a reclaim thread. So if you're trying to reclaim some memory that it says, hey, it's been marked as dirty. It was, laundry memory in the old FreeBSD days. So now it's going through and reclaiming that memory. So instead of blocking, waiting for a hash lock, it's just saying, okay, let's skip that one. We gotta evict something else instead, rather than blocking on a RAM eviction, which should be really, really fast. So blocking in that case could be a really short time. But in terms of computer memory, hey, nanoseconds start to count there.
Okay. And then we also have write issue task queue priorities. So we're standardizing write task queue priorities across all platforms. Now they're using a symbolic constant instead of going and hard coding platform specific values. Again, mostly a back end housekeeping thing, but I'm sure that'll be helpful down the road. Just good cleanliness here.
Yeah, standardizing across platforms, almost as if there's some other, instruction set that people are trying to get OpenZFS working really, really well on.
Oh,
yeah. What a coincidence.
Weird. I can't imagine.
Yeah.
I can't imagine.
Yeah. We have a nice async writeback fix for the Linux-based ZFS. So it unlocks the pages immediately after a write instead of waiting for disk I/O. So this fix a truncate hang and some writeback stalls that could actually block until the full transaction group timed out. So it basically says, hey, once you've flushed a page out of the transaction group, you can actually start flushing it from memory. You don't have to wait for things to complete. As long as it's landed in the ZIL or somewhere that's safe, that could be flushed out.
Yeah. Okay. Well, one we'll mention doesn't affect us. Zvol Linux 4.19 crash fix. Again, we're on kernel 6.12, so not as important for us, but it did fix an issue for people running the older kernels with panics around Zvol operations when the block queue is using a valid CPU ID when the request context was uninitialized. But again, nothing to worry about on the TrueNAS side. We haven't seen a 4x kernel in ever.
I was going to say, what did Angelfish launch on? I'm pretty sure it was still kernel 5 at that point.
It was 5.2 or something.
Yeah.
I'd have to go back and check. So I think this even predates us, but still good to see it land.
Yep. We got some formatting fixes, some readability of Slack alerts for people using a particular, Z daemon. I don't think that one's used in TrueNAS, but it's good for those who, for systems we integrate with. If you're taking your TrueNAS snapshots and you're replicating them out to a different ZFS system, hey, it's, get your reporting set up and working there when you upgrade to 2.3.4 on the other side. We also got a couple of allocation fixes. We got one for the Z standard compression. So when you're doing, it's really for really high CPU count systems. We're talking like 192 cores. It has to do with fixing mostly warnings. It talks about, saying when you're doing the vmem allocs for whether it's a Z standard backed memory pool, multi-list structures, it was just kind of spamming your logs with warnings. So in this case, more information is great, but, false warnings are not great because they flood out the information we're actually looking for.
Makes sense. And then we also have some improvements to the mounting services. There's a templated mounting service now for per dataset systemd mount controls. Oh, that sounds nice. Enables selective recursive mounting at boot. Very handy. I'm sure some of the Linux admins will appreciate that. And last but not least, we have some ARC summary enhancements. So adds uncompressed size metric to the ARC summary for better compression ratio visibility. Again, always helpful since this is how we look at performance and do performance troubleshooting and all that. So the more data we have there, the better.
Exactly. And the idea of more data, a lot of people may not realize that even in the ARC, that data is compressed. So if you have compressed blocks on disk that are getting, a 1.5 to 1 or a 2 to 1 compression ratio, you're actually getting that still in your primary ARC. So you might have 128 gigs of ARC up in primary memory. If you got a 2 to 1 compression ratio, you're serving 256 gigs of hottest data out of RAM. You didn't have to pay for it. You're literally, in this case, you downloaded more RAM. It's working for you.
Yeah, no, that's awesome. RAM doubler actually is a thing now.
RAM doubler worked.
Yeah. One thing I wanted to call out real quick, because we mentioned this on a previous episode. For those of you who are running Goldeye Beta or the new RC1 when it drops, we also added there's the new ZFS Rewrite functionality, which has gone in. So again, there's a reference. You can go look at the previous episode where we went into that in depth. We would, of course, love to hear from folks who are trying to use that as a refresher for those who are wondering what rewrite is. Anytime you've added new VDEVs and wanted to rebalance, people have been doing kind of hokey third-party scripts to go and basically move and copy files around to force ZFS to reallocate the blocks. ZFS Rewrite does that all under the hood at the ZFS layer, so you can run it transparently from your applications up top, and you don't have to go run crummy shell scripts or run a Python script or whatever.
Yeah, the key piece of that is that you don't have to worry about respecting file locks anymore. In that case, you can continue writing to and working with those files that you're doing the rewrite on, as opposed to those pure userland scripts, which were basically doing the same thing as, hey, copy this file A to B, delete the original and rename it back. So if somebody wrote something between, steps 1 and 2 there, where after you've copied, somebody writes it, okay, delete this. Well, oops. So in this case, with it being baked into ZFS Rewrite, that there's no gap in there. We've closed that loop. All the moving just happens underneath at a different level.
Less potential for hilarious foot shooting. But one interesting use case I wanted to call out is the special VDEV use case. So I actually confirmed with the lead developer on this one before I brought it up here, was the ability, if you're on a spinning disk system and you're got a lot of small block files, all those kind of things, and you've always been tempted, I should go get some SSDs and do a special VDEV and configure it for small block storage. The rewrite command handles that gracefully as well. So if you are one of those folks who wants to go and accelerate your small block files, you should be able to attach your special VDEV, configure it for small block files, and then run the ZFS rewrite command, and ZFS will happily reallocate and move that data off of the data VDEVs onto the special VDEV as well, which could be an interesting way to see if you can get some performance.
Yep. Just make sure that when you are using those special VDEVs, you remember a couple things. One of them is that special VDEV is critical to your pool. Make sure you give it some redundancy, a minimum of a mirror, possibly even a mirror
minimum,
possibly even a mirror 3 if you've got, a RAID Z2 or a RAID C3 for your data VDEV. And on that front, if your data VDEV is a RAID Z anything, once you've added that special VDEV, it's there for good, because VDEV removal will not work if you have RAID Z VDEVs in your pool. So make sure you're going to add it with at least that mirror, and make sure that you sort of are confident that, so you're saying, hey, I want this in here. It's going to work. I've taken the, proper measures in advance, and I have my redundancy ready.
Absolutely.
ZFS safely, folks.
Absolutely. Well, one last thing we want to tease you with here a little bit. So obviously Goldeye's coming. We're, again, RC1's just around the corner. That's starting to look to be in pretty good shape. But we wanted to talk to you about one of the other features that's been cooking in the background for the next major release, 2604 Halfmoon, which will, of course, release next year, April, although betas will start earlier in the January-February timeline. So one of the features we've mentioned as being committed for that release is Spotlight support. For those of you who are on Mac and using Finder, that's the search integration built in. It's been something that's been in Samba for some time, but we had to go do work to add it to TrueNAS. You need indexing agents, all that. We've just started merging the infrastructure pieces into the build, which will allow this to work. The early work in progress code we have shows some promise. It's starting to work pretty well. We're already testing with Mac clients. It's really sexy to see those nice kind of instant search results come back, including all the variety for the advanced things Spotlight supports, like kinds, where you can say kind image and it shows me all the images, or then put filters on that further, or even searching via metadata. So I can type in John and see the documents I have where it's mentioning one of the Johns here in the company. Cool. And that's all, again, instant, coming out of a database and not having to walk the tree every time, which has been the current.
There's still issues searching for Chris's because there's too many of us here.
Yeah, it doesn't help you with that. You need to have a little bit more refined search parameters there. But what we're seeing now is it's working pretty well. Searches are crazy fast, so that's cool. Where we're working on improving is the indexing side. So obviously I'm never content with it. We want the goal to be, indexing 1 billion plus files on reasonable hardware. Again, reasonable. We're starting on lower end hardware here to see if we can get the maximum performances. We really want to get it to where the bottleneck's actually the drives and not the indexing agent itself. So that's what's being worked on. Seems achievable. We're still knee deep into that effort, but we're looking forward to getting this into people's hands in a nightly image, probably in the next couple months, to get some wider testing and sample sizes. We'll be curious to see what kind of file loads people throw at it and how it performs in those cases. But still, this has been a long time coming. We're excited to see it start to land.
Yeah. For those of you who have a macOS system and you're interested in testing it out, if you do have a secondary machine and you're willing to do that, look for that announcement when we start dropping the Spotlight support into the Halfmoon nightlies. Get in there, poke around with it, share some benchmarks with us. You say, hey, I got a couple million files on here. It took, 2 minutes of it thinking about it to index everything, and then I was good to go. That's the kind of information we need. And like Kris says, we're trying to make sure this works on, reasonable hardware. You don't want to need a 64 core Epic or something at home. You don't. We're not going to do a Borderlands 4 here, folks.
No, I'm trying to do like mini class hardware to start, because if I can optimize it there, it'll scale up nicely to all the much bigger systems. But again, being worked on heavily, it's exciting to see, and we'll look forward to talking more about that in a future week episode. That's our episode. Excited to see RC1 get into folks' hands in the next few weeks. As usual, be sure to like and subscribe to not miss any future episodes. And also, if you have any questions or comments you'd like us to address on a future episode, send that in to t3@truenas.com. In particular, I'd really love to hear any feedback you have on Goldeye. What did you like? But even more importantly, what did you dislike? We're embarking on a journey to really make our UX, the user experience, even better in coming versions of TrueNAS, and that feedback can greatly assist us in that process. Until next time.